Before we begin our discussion of variables in earnest, I think it's worth pointing out that even though I'm using PowerShell ICE, you have a variety of options if you'd like to write some script. The first thing to note is that you can write scripts interactively in the console or in the command shell. But you can also use any editor that you want. All you really have to have is a text file that has the PS1 extension, and PowerShell is going to recognize that as a script. So like I said, you could use any text editor, even Notepad, and there are a variety of decent third-party editors specifically for PowerShell. But in these demonstrations, I'm using PowerShell Interactive Scripting Editor 3.0. All right, so with that said, let's talk about variables. In PowerShell, variables are weakly typed, and what that means is you don't have to tell PowerShell what type of variable you're creating. It simply infers the type based on the assignment of a value to the variable. All variables in PowerShell start with a $sign symbol, and it's worth noting that unlike C#, variable names are not case sensitive. In fact, nothing in PowerShell is case sensitive. To assign a value to a variable, all you have to do is use the equal sign, but there is a commandlet that you can use alternatively, which is set value. There are also a lot of predefined variables depending on the module that you're using. There may be more than the ones I'm going to talk about today. And others are created for you automatically based on the context of the operation that you're performing. All right, so let's move on over to the PowerShell Interactive Scripting Editor and start our exploration of variables programmatically. Okay, so here we are in PowerShell, and although I'm scripting, the demonstration I'm doing right now is going to be pretty simple, so I'm going to go ahead and hide the scripting pane and just do this from the command shell itself. Now, like I said, creating variables is really easy. All you have to do is assign the variable. And so, since every variable name starts with a $sign, I'm going to just create a new variable called foo, and if I say foo is equal to ABC, I don't get any output from the console window, but if I check it here in a second, typing in foo, I get the value ABC back. Now the assignment that I did here was a string, and so foo is actually a string. I can tell that by using the getType method, which all .NET objects have, and it tells me that this is a public string based on system object. Now, in addition to the ability to just do the assignment, there are some commandlets that I can use instead. You'll see these used occasionally in people's scripts where they're dealing with variables where they want to do a lot of initialization behavior up front, because these will allow you to do things in one line of code that might otherwise take several lines of code. So the first one we're going to look at is called setVariable. And setVariable is really simple as far as its base syntax is concerned. It takes the name of a variable, and so we'll call this bar. Now notice I'm not using the $sign here because bar is the parameter that I'm passing into setVariable. I'd give it its name, not the variable itself. This is a very subtle point, but if I called setVariable $bar, PowerShell would try to interpret bar, and if it had a value inside of it, it would use that value as the name of the variable instead of bar itself. Okay, and so I'm going to say that I want to set the value of bar, and we'll give this a value of 1, 2, 3, 4. And if we check the value of bar now, we can see that it is 1, 2, 3, 4. And bar, of course, is an integer. Based on the value that I assigned to it. A set variable has some aliases that you'll commonly see. The alias that people use if they're trying to do this in shorthand is SV. We can see that SV is the same thing as set variable. Now, I'm not going to get into any depth at this point about the other options that I can use with set variable because they're all about controlling scope and visibility, and those are not topics that I'm ready to talk about just yet. So moving on from set variable, then of course we need some way to read the value of variables if we're going to use a commandlet, and so there's also a getVariable command. And once again, this takes the name of the variable without the $sign. This also has an alias, which is GV. And then finally, we have the clear variable function. And so if we clear the bar variable and then try to test for its value, you see that we get nothing coming back as value. Within a given PowerShell session, there are always some automatic variables that are available to you. You can read about all of these by using get help and passing in about automatic variables. And the article is actually quite good that describes all of the ones that are available, but there are some that I would like to call out specifically. Before I do that, I want to note that most of these are read-only variables or constants. So there are constants for all of the base values that you might do comparisons against. So for example, there's a $true variable, which is equal to the value of true. There's one for null. There's one that will give you your path with drive. PWD is, I think, somewhat poorly named because when I see it, I think of password, but that's actually path with drive. And there's one in there that you can use to find out the current version of PowerShell that you're using. All right, so let's take a look at these. Okay, so let's start off our examination of the automatic variables by having a look at true. IntelliSense is nice. It comes up and tells me that there is a variable there called true, and its value is equal to true. Now, true is a constant. It's read-only. I can't change it. So if I try to say that true is going to be equal to 3 now instead of the value true, I'm going to get an error telling me that it can't overwrite that variable because it's read-only or constant. Now, there are all sorts of really useful environment and session information that's available to me inside of these PowerShell sessions. So I can read what the current path with drive is with PWD, and I can get the current process ID with PID, and I can even find out who I am by looking at the environment and seeing what my username is. Now, if I'd like a list of all of the automatic variables that I have in my current session, I can just issue a call to get variable without any arguments. Whoops, it's not a variable. All right, so if I do this, I can see that I have a profile and a value for null, and there's path with drive and all sorts of fun stuff. And if I create a new variable, I'll make one called foo and make it equal to 4 and run get variable, I can scroll up here and we can see there's foo. Now, in the previous demonstration, I showed you how to use clear variable, which would just clear a variable's value, but there's also one called remove variable that I can use to get rid of the variable completely. So now, if I get the variable list once again, there's no foo. The last one I want to touch on before we move on from this intro is a very handy variable called error. And I've done lots of wrong things inside of this PowerShell session. I've used it for several demonstrations where I just clear the session or CLS to clear the console window each time. I've done some things off camera where I was messing around. And so if I take a look at error, I can see that I get all sorts of input back, and these are all of the errors that have been made inside of the session. You can see that I'm a really dangerous guy. I'm always causing errors to happen. But if I want to get the most recent one, this acts as a stack. So the most recent error that happened always gets written into the first slot of the collection. And so if I just check error for its first index, I can see that the last error that I got was that I couldn't overwrite a variable because it was read-only or a constant. PowerShell strings are simply .NET strings, and so that means that all of the standard .NET string objects and methods apply. If you know how to use string.format or string.contains or string.replace in .NET, you can use those in PowerShell. But PowerShell also adds some convenience in terms of its comparison operators. So in addition to the string methods, there are also operators that you can use, like the like operator or the contains operator in order to evaluate strings when you're doing conditional operations. Just like in .NET, you can concatenate strings with the plus symbol, but you can also simply embed the string variable in a literal and you'll get the exact same result. All right, so let me show you how that works. It's really simple. Let's jump over to PowerShell now. So let's start with some simple concatenation. I'm going to make a variable called s here, and I'm going to just say I, and then plus, and love, and then plus, and then PowerShell. Right, so if we check out the value of s, we'll see that it's I love PowerShell. All right, now I can also concatenate by just using the variable and embedding it right in a string. So if I were to say Doug says, and then just put s right in the string and evaluate this, you can see it says Doug says I love PowerShell. All right, so what you already know about strings from .NET and C# or VB.NET applies to PowerShell. So you can use all of the string methods that you're used to. So if we did something like ABCD and did a contains for BC, this is going to evaluate to true. But PowerShell also has some convenience comparison operators, actually a whole bunch of them, and they're richer than what you find in C#. So I could also write ABCD and then use the match operator, not math, but match, and check this for BC. And we can see that this is true. Note that the string comparison here is not case sensitive. Generally speaking, PowerShell is not case sensitive, although there are operations where you can use to specify that you do want things to be case sensitive. So one of those is just passing a C, which is the case match, and that's false. But if I were to change this to uppercase BC, that's true. There's also a very convenient operator that's similar to match, but a little bit confusing in that it's different. It's called like. So if we do ABCD like BC, we can see that this is actually false. But the like operator takes wildcards. So I could change this to search for splat, and the wildcard characters are the same as what you're used to DOS. So splat means match any set of characters, and question mark means a single character. And we can see that ABCD is like the wildcard splat BC question mark. Now finally, I'd like to point out that all of the string methods are available to you as well. You can call the static method of any .NET class by just specifying the class and then using : and you can see here that we have all of the stuff that you're used to if you're a .NET developer. So one of my favorite .NET commands, period, that I use a lot in my code is the string format command, and so I could do a little string format here, and we'll just make this a little hello world demo. So we'll say hello Doug, and evaluate this, and you can see that it works just as you would expect, passing hello into the 0 slot and Doug into the 1 slot. Quite often our scripts deal with collections of things, and PowerShell, being based on .NET, has got lots of different types of collections that you can build, but the two easiest to use and the two that you'll see most commonly are hash tables and arrays. An array is simply a list of simple values, whereas a hash table is a list of key value pairs. Each of these things can be created declaratively without having to create a new object, and each one of them is very common in pipeline operations. But the way they work isn't always exactly intuitive. So let's start off by creating a hash table and an array. and then we'll get a little deeper into how they behave. All right, so let's start off by making an array. An array, like I said, is just a simple collection of values. I'm going to make a new array called cars. And in PowerShell, the syntax for an array is really simple. You just open and close a paren, and then you just enter in your values separated by commas. So we'll make cars that are Chevy, Ford, and Honda. And now if I test for cars, you can see that I have a list of Chevy, Ford, and Honda. I can fetch each one of these based on their ordinal position in the array. So the first one, which starts at 0, is Chevy, and the second one, of course, is Ford. One thing that's really great about arrays is that they can participate in pipeline operations. All right, so let's change the declaration of cars here. We're just going to make a new one, and we'll move Chevy into the third spot. And so now that if we look at the second slot, we've got Honda. Let's just sort this. So we're going to take cars and pipeline this into the sort object commandlet, and we can see that it just does a nice job of sorting our array. Now there is something that's a little bit confusing about arrays, at least it was for me when I started, and that is that if you use IntelliSense, it looks like you can add new elements to the array. But if you try this, you're going to get an error, and it tells you that the collection was of a fixed size. Well, that's no good. I mean, you may commonly need to create arrays that are going to have entries written into them as it goes along with some operation. Well, the reason for this is just a peculiarity having to do with the implementation of the array class in PowerShell, and add just really isn't implemented. So what you actually can do is instead use plus equals, and we'll make this one fiat. And what happens when you run this operation is it actually copies the original array into a new array that's one size bigger with a new value. So now if we sort cars, we can see we have Chevy, Fiat, Ford, and Honda. All right, so arrays are easy, and so are hash tables. And to create a hash table is very, very similar, except the syntax is a little different. Instead of using a set of parens, we use a set of curly braces. And what we need to do is enter in our values separated by a semicolon. These are name value pairs. And so we'll say we have a person whose name is Fred. And we'll say Fred has a value which is equal to 90, because Fred's nice and smart. And then we have another entry named Bob. Bob's not quite as smart as Fred, and his grade is 40. All right, and if we look at grades now, we can see that we get this nice little formatted table where we have Bob 40, Fred 90. And we can check to see what's in our hash table by checking contains key and contains value. So if we do contains key for Bob, that's true, but if we do for Bobby, that's false. There's a little bit more to hash tables than meets the eye, so let's jump back over to the slides and talk about that, and then we'll come back and demo just a little bit more. By now, it should come as no surprise to you that a hash table in PowerShell is based on the system collections hash table class from .NET. Now, .NET hash tables are intrinsically unordered. So there's no guarantee that when you try to iterate through the hash table later on that you'll get the items back in the same order in which they were added. Well, this is a problem for a lot of people, and so in PowerShell 3 they allowed the creation of ordered dictionaries with the ordered operator. Now another common gotcha that you'll run into is that hash tables don't behave quite the way you might expect in pipeline operations that involve sorting and filtering, or really anything for that matter. And so if you want to sort and filter, instead of using the hash table, you need to get the hash table's enumerator by using the getEnumerator function. All right, let's examine that behavior a little bit more closely, because this is definitely something that will throw you up sooner or later. All right, so here we have a hash table named grades, and it's got a couple of values in it. One is a key value pair called Bob and 40, and the other one is a key value pair called Fred and 90. All right, so let's observe the problem I'm talking about with pipeline operations involving filtering and sorting. All right, so what I'm going to do is I'm going to say that I want to do grades, and we're just going to sort this. And we'll sort it by the value. All right, let's run this. Well, it looks like everything is working fine because 40 comes before 90, but let's switch this up a little bit and say that we actually want this in descending order and run it again. And we can see something really strange is happening here, which is that it still says 40, 90, and of course 90 is greater than 40. All right, so the fix for this is to simply use getEnumerator and then do the sorting on that. So we would take this grades and say getEnumerator, and now when we run the operation you can see that it has sorted it correctly. And what I just showed you applies to filter operations as well as sorting operations. So if we were to try grades here, and instead of using sort we said where, and we'll say where the name was equal to Bob, well, we get nothing back. But if we get the enumerator, works like a charm.